Lesson 11.4 is about areas of regular polygons. Regular polygons are polygons that have all sides the same length and all angles the same measure. So they're equiangular and equilateral. And if we were to take a regular polygon and inscribe it in a circle, the center of the circle we would also call the center of the polygon. And from the center of a circle to a vertice would be called a radius. Okay? And we're going to learn a new term. From the center of the circle, or the center of the polygon, if you bisect, you go through with a little segment in altitude to a side, they call that an apothem. Okay, so all regular polygons have centers and radiuses and apothems. So to recap, this is a hexagon, and I have it inscribed in a circle, but whether or not it's inscribed in a circle, it has a center. So the hexagon in any regular polygon has a center. Okay, then if I go from the center out to a vertice, that's a radius, and it's actually called a radius of the polygon. And then if I go from the center to the midpoint of a side of the polygon, so I hit it with an altitude, I call that little segment the apothem. So it turns out that the formula for finding the area of any regular polygon is 1/2 of the apothem, which we're going to use a little a for, times the perimeter. Okay, so the P is the perimeter of the figure, and the A is the apothem. Now, why that's true? Well, we'll explore that a little in a minute. Okay, so let's start with an example of a regular hexagon, a 6-sided figure where each side is 8 long. Okay, so I'm going to draw in radiuses to each of the vertices from the center. Okay, now what's going to be the angle, the measures of each of those central angles? Each of those central angles is going to be the full 360 degrees, like the circle that it's inscribed in, divided by 6, or each of those is going to be 60 degrees. Now, if I divide each of those in half by putting an altitude down in the middle of each of those triangles, I will get 30-degree angles. So I'm going to do that. Now, these pieces I'm adding are called apothems, aren't they? So I'm creating a whole bunch of little right triangles. Okay, so let's just take one of them as an example. Let's take this one at the bottom. If the whole bottom side was 8, I know I've just divided it into 2 pieces that are each 4. If I focus on this little triangle down here, I know how many of those are there. Well, there are 12 of those, aren't there, in the whole hexagon, 12 of those little triangles. So if I can figure out the area of one of those little triangles, I can multiply it by 12. So I know that the bottom is 4. Now, I already said that the measure of the central angle is 60, so the measure that's at the top right here, now I've divided in half, that must be a 30-degree angle. So the 4 down here at the bottom represents short leg of a 30, 60, 90. So the hypotenuse will be twice that, or 8, and that's the length of a radius. And then the apothem, which is long leg, will be 4 times the square root of 3. So the area of one of those little triangles is 1/2 base times height. So 1/2 of 4 times the height of 4 root 3. So that is 2 times 4, so that's 8 root 3. Now, we already said that there are 12, and that the area of that little triangle is 8 root 3, and there are 12 little triangles. 12 times 8 root 3 is 96 root 3. Okay, so let's see how we get that 96 root 3 using our formula that the area is going to be 1/2 of the apothem times the perimeter. So we already know the perimeter of this hexagon is 6 sides at 8 each, so that's 48. And the apothem we figured out is 4 root 3. So using the formula, area equals 1/2 apothem times perimeter. The area should be 1/2 of the apothem of 4 root 3 times the perimeter of 48. So I get 2 times 48, or 96 root 3. Okay, so using the formula is obviously much quicker, but that's where it comes from. And you can see it proved with just taking the area of one little triangle and finding how many there are and multiplying that area by the number of little triangles you can build. Anyway, we're going to use 1/2 of the apothem times the perimeter for our formula. Okay, so we're going to be using a lot of our 30, 60, 90, and 45, 45, 90 triangle, right triangle knowledge in this unit. Okay, and I'm going to go through the proof of this in class, but let's take each of these regular polygons, a triangle, equilateral triangle, a square, and a regular hexagon, and I'm going to draw, I've got centers drawn in, I'm going to put in a green radius in each of them, and I'm going to put in a blue apothem. Okay, so those are the apothems, and the green are each of the radiuses. Okay, now, because of the central angle being at the top, we end up in every one of these cases with a few things that, because these little right triangles down here, that will always be true. If the figure is a triangle, 3 sides, it means that this angle down here on the bottom is going to be 30 degrees. So I use the 3 from the 3 sides to remember 3 means 30 degrees is the bottom angle. If I have a 4-sided figure, the central angle will be 90 degrees, and when I divide that I get 45 at the top. So this is a 45-degree angle also at the bottom. So I remember the 4 from 4 sides to remind me of 45. So if I'm looking at a square, I have a 45-degree angle on the bottom. By bottom I mean if I'm sitting looking at the figure like this. Okay, and so then as 6 sides, my central angle will be 360 divided by 6, or 60, and then when I divide that in half, it's a 30 at the top and a 60-degree angle at the bottom. So I use the 6 and 6 sides to remember the 60-degree angle is on the bottom. So when you get really used to doing these, you don't have to work it out every time. Just remember 3 sides, 30 bottom, 4 sides, 45 bottom, 6 sides, 60-degree bottom. And then we can use those special right triangle relationships to find lengths of radiuses and sides and apothems. Okay, so 3 quick examples, one with a triangle, one with a square, and one with a hexagon. So first I have an equilateral, let's just say that this is an equilateral triangle, and the radius is 8 from center to a vertice. So I'm going to sketch in an apothem, and I'm going to use the fact that I now remember that 3 sides, this is a 30-degree bottom. So if 8 is the hypotenuse of a 30, 60, 90 right triangle, then the apothem here is 4. And half of the bottom side, the side length here is long leg, and so that's 4 root 3. Okay, and I know I've got the same thing on the other side, so I'll have a 4 root 3 here. So as far as the formula, the area is 1/2 the apothem times the perimeter. I can say, okay, so the area is 1/2 the apothem, which is 4, times the perimeter. Okay, so the perimeter, across the bottom now, I have this whole length is 4 root 3 plus 4 root 3, or 8 root 3. And so the perimeter is 3 sides at 8 root 3 each units. So this is 24 root 3. So back to my formula, 1/2 the apothem of 4 times the perimeter of 24 root 3. So I get half of 4 is 2 times 24 is 48 times the square root of 3 square units. Okay, in this next one I have a regular polygon, a square, a four-sided figure. So I'm given that the apothem is the square root of 3, so I'm going to sketch that in. And I have to find the area. So I want to draw in a radius. And I know that this is 4 sides, and so I've memorized this is a 45-degree bottom angle here. And I know that this is a 45, 45, 90 little right triangle. So if that is root 3, the apothem, this half a side here is root 3, and when I multiply those by root 2, I get a radius of root 6. But I really don't need to know that radius because I've got the apothem and I can find the perimeter. I know that the other half of that side is root 3 as well. So root 3 plus root 3 gives me a side length of 2 root 3. And the perimeter is 4 of those. So 4 times 2 root 3, or 8 root 3. Okay, so the area is 1/2 the apothem of square root of 3 times the perimeter of this figure, which is 8 root 3. So I get 1/2 times 8 times root 3 times root 3. So 4 times root 3 times root 3 is 3. So I get an area of 12 square units. Okay, last example. I have a regular hexagon here. I'm going to draw in the center. I'm given that the perimeter is 24 root 3, and I have to find the area. So this is a good one. There are 6 sides, and if the whole perimeter is 24 root 3, and I divide by 6 sides, it means that each of those sides has a length of 4 root 3. So if I'm 4 root 3 here across the bottom, I know that if I draw in an apothem, that half the way across the bottom is 2 root 3. And I'll draw in a radius. Okay, so let's look at what our angles are here. I remember 6 sides, 60 bottom. So if that's a 60-degree angle, I have a 30-degree angle on top. And 2 root 3 is the short leg. So I know to find the apothem, I multiply short leg by root 3. So 2 root 3 times root 3 is 2 times 3, or 6, for the apothem. So I already had the perimeter, and now I've got the apothem, so I can use the formula. So the area is 1/2 the apothem of 6 times the perimeter of 24 root 3. So I get half of 6, which is 3, times 24, which is 72 times the square root of 3 square units. And that's it today for areas of regular polygons.